Welcome back. In the previous video, we discussed some foundational concepts related to software quality models. We also discussed a software quality definition model, that is McCall's model. So in this video, we will discuss the remaining quality definition models, that is Boehm's model, FURPS, and ISO 9126. So the second quality definition model we discuss here is Boehm's model. Boehm's model attempts to qualitatively define software quality by a given set of attributes and metrics. Boehm's model is similar to the McCall's quality model in that it also presents a hierarchical quality model structured around high-level characteristics, intermediate-level characteristics, and primitive characteristics, each of which actually contributes to the overall quality objectives. Well, the high-level characteristics they represent high-level requirements of actual use to which evaluation of software quality could be put. The high-level characteristics address three main questions that a buyer of the software has, and these questions are related to uh, as is utility. That is, how well, for example, easily, reliably, efficiently can I use this product as it is. Maintainability, that is how easy it is to understand, modify, and retest the product. Then portability, that is, can I still use it if I change my operating environment. Then the intermediate level characteristics represent Boehm's 7 quality factors that together represent the qualities expected from a software system, and these include portability, reliability, efficiency, usability, testability, understandability, and flexibility. So we see each of these factors one by one. Portability, that is, the code possesses the characteristic portability to the extent that it can be operated easily and well on a computer configuration other than its current one or current configuration. Then reliability, that is, the code possesses the characteristic reliability to the extent that it can be expected to perform its intended functions satisfactorily. Then efficiency, that is, the code possesses the characteristic efficiency to the extent that it fulfills its purpose without waste of resources. Then usability, that is, code possesses the characteristic usability to the extent that it is reliable, efficient, and human engineered. Then testability, that is, the code possesses the characteristic testability to the extent that it facilitates the establishment of some verification criteria and supports evaluation of its performance. Then understandability, that is, the code possesses the characteristic understandability to the extent that its purpose is uh, clear to the inspector of the code. Then flexibility, that is, the code possesses the characteristic modifiability to the extent that it facilitates the incorporation of changes once the nature of the desired change has been uh, determined. Then the lowest level structure of the characteristic hierarchy in Boehm's model is the primitive characteristic metric. The primitive characteristics provide the foundations for defining quality metrics, which was also one of the goals when Boehm constructed this quality model. Consequently, the model presents one or more metrics, supposedly measuring a given primitive characteristic. Here in this figure, we see the hierarchy where we have general utility at the top of the hierarchy. Then At the next level, we have three high-level characteristics that we discussed in the previous slide. Similarly, seven intermediate level characteristics that we also saw on the previous slide, and in the primitive level characteristics, which are also called as low level characteristics. You can see that portability is included as both a high level and an intermediate level characteristic. Then Boehm classified the characteristics into the primitive characteristics, which I just mentioned, as the low-level characteristics, and these characteristics they include device independence, accuracy, completeness, consistency, device efficiency, accessibility, communicativeness, self-descriptiveness, legibility, structuredness, conciseness, and augmentability. Here we see a comparison of the Boehm's model with the McCall's model. Though Boehm's and McCall's model might appear similar in some respects, the difference is that McCall's model primarily focuses on the precise measurement of the high-level characteristics, whereas Boehm's quality model is based on a wide range of characteristics with an extended and detailed emphasis on primarily the maintainability characteristic. So in conclusion, we can say that Boehm's model focuses a lot on the model's effort on software maintenance, cost effectiveness, which he states is the primary payoff of an increased capability with software quality considerations. Then the next model we discuss here is FURPS. FURPS model is perhaps somewhat less renowned model that is structured in basically the same model as the McCall's and Boehm's model. This model was originally presented by Robert Grady and was extended by Rational Software, now which is called IBM Rational Software, into FURPS Plus. FURPS stands for functionality. That is, F signifies functionality, U for usability, R for reliability, P for performance, and S for supportability. So we see each of these characteristics one by one. So functionality. By functionality, we mean that the system must meet its functional requirements, and usability may include like human factors, statics, consistency in the user interfaces, online and context-sensitive help, similarly wizards and agents, user documentation, and other training materials. Then reliability, that is for example, frequency and severity of failure. They are in fact an indicator of the reliability of the system. Similarly, recoverability, predictability, accuracy, and mean time between failure. In fact, these are some metrics that help us in understanding the concept reliability. Then performance. Uh, 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 it actually imposes conditions on like the functional requirements such as like speed, efficiency, availability, throughput, response time, resource utilization, etc. Then supportability, and this may include factors such as testability, extensibility, adaptability, maintainability, compatibility, configurability, serviceability, and installability, etc. The first categories are of two different types. So that is functional, which is in fact F here, and non-functional, which are URPS, that is usability, reliability, performance, and supportability. An important point here regarding FURPS model is that unlike Boehm's and McCall's model, this model considers functionality explicitly as a quality characteristic, which is not the case with the two mentioned models. Usually, it is by default understood that a particular software system will meet its functional requirements. So it is not specified as a quality characteristic. Rather, the quality attributes such as usability, reliability, performance, etc., are emphasized by the models. But here in first model, explicitly considering functionality as the quality characteristic signifies the importance of fulfilling the functional requirements and meeting the specifications that we also had discussed during our definitions of software quality. The next quality definition model we discuss here is ISO 9126. This standard is also based on the McCall's and Boehm's models. That is, ISO 9126 also provides a hierarchical framework for quality definition and in fact provides quality characteristics that are in fact further categorized into sub-characteristics. Being structured in basically the same manner as these models such as Boehm's model and McCall's model. ISO 9126 also has some distinction from the models. That is, again, it includes functionality as a parameter. There are six top-level quality characteristics in this model, uh, with each associated with its own exclusive, that is, non-overlapping sub-characteristics that we will discuss in this video. So the top-level attributes in this model include uh, functionality, reliability, usability, efficiency, maintainability, and portability. By functionality, we mean that like what is actually needed, whereas reliability refers to that does the software or the system function correctly. Similarly, usability relates to the efforts to use, and efficiency relates to resources needed in like performing the certain designated tasks, whereas maintainability has aspects that are related to, for example, corrective maintenance, improvement maintenance, and adaptive maintenance. Similarly, portability is that is moving the software from one environment to another. Here is a detailed representation of this model. As we can see that there is a strict hierarchy where no sub-characteristics or sub-factors are shared among quality factors or quality characteristics. In the upcoming slides, we will discuss each of the factors and the corresponding sub-factors to gain more insights about this model. The first quality factor of ISO 9126 we discuss here is functionality, which relates to a set of functions and their specified properties. The functions are those that satisfy stated or any implied needs. Functionality has several sub-characteristics such as suitability, accuracy, security, interoperability, compliance. So by suitability, we mean that the attributes of software that relate to the appropriateness of a set of functions for specified tasks. The accuracy is the attribute of software that bear on the provision of right or agreed results or effects. Whereas security is the attribute of software that relate to its ability to prevent unauthorized access, whether that is accidental or deliberate to any programs and any portions of data. Then interoperability refers to the attributes of software that relate to its ability to interact with specified systems. Then compliance. Compliance relates to attributes of software that make the software adhere to application related standards or uh, conventions or regulations in laws and similar prescriptions. Then the second factor of ISO 9126 is reliability, which can be defined as a set of attributes that relate to the capability of software to maintain its level of performance under stated conditions for a certain period of time. So, reliability has sub-factors that include maturity, fault tolerance, recoverability, and compliance. So, by maturity, we mean that the attribute of software that relates to the frequency of uh, uh, failure in the software system. And fault tolerance refers to the attributes of software that relates to its ability to maintain a specified level of performance in case of software faults or in case of any problems in the software system. Whereas recoverability is the attribute of software that relates to the capability to re-establish its level of performance and recover the data directly affected in case of a failure and on the time and effort needed for it. Whereas compliance has the same meaning and perspective that we have already discussed in case of functionality. The third factor of ISO 9126 is usability, which refers to a set of attributes that relate to the effort needed for use and on the individual assessment of such use by a stated implied set of users. Usability has several sub-factors that include understandability, learnability, operability, attractiveness, and compliance. So by understandability, we mean that uh, the attribute of software that relates to the user's efforts for recognizing the logical concepts and their applicability. And learnability refers to the attributes of software that relate to the user's effort for learning its application, for example, operation control, inputs, outputs, etc. Then operability refers to the attributes of software that relate to the user's efforts for operation and operational control. Whereas attractiveness refers to something which is visually pleasing, particularly in context of the interfaces of the system, whereas compliance has the same concept and definition that we have already uh, discussed. Then the next factor is efficiency, which is which refers to a set of attributes that relate to the relationship between the level of performance of the software and the amount of resources used under stated conditions. And efficiency has several sub-factors that include time behavior, resource behavior, and compliance. So time behavior, in fact, refers to the attribute of software that relate to response and processing time and on throughput rates in performing the intended functions. Uh, then resource behavior relates to the attribute of software that refer to the like amount of resources used and the duration of such use in performing its functions, whereas compliance we have already discussed that it has same perspective here. The fifth factor of ISO 9126 is maintainability. Maintainability refers to a set of attributes that relate to the effort needed to make specified modifications in the software systems. And maintainability has several sub-factors such as analyzability, changeability, stability, testability, and compliance. Uh, Analyzability refers to the attribute of software that relate to the effort needed for diagnosis of deficiencies or causes of failures, or for identification of parts or subsystems of the system to be modified. Whereas changeability refers to the attribute of software that relate to the effort needed for modification, for fault removal, or for any other changes in the system. Whereas stability refers to the attribute of software that relate to the risk of unexpected effects of modifications in the software systems. Then testability. By testability, we mean that the attribute of software that relate to the effort needed for validating the modified software, whereas compliance is the same. Uh, then the next factor is portability, which is in fact a set of attributes that relate to the ability of software to be transferred from one environment to another. And portability has several sub-factors that include adaptability, installability, conformance, and replaceability. So, what is adaptability? Adaptability refers to the attribute of software that relates to the opportunity for its adaptation to different specified environments without applying other actions or means than those provided for this purpose for software configuration. Whereas installability is the attribute of software that relates to the effort needed to install the software in a specified environment. Then conformance. Conformance is the attribute of software that make the software adhere to standards or conventions relating to portability. And finally, replaceability. This is the attribute of software that relates to the opportunity and effort of using it in the place of specified other software in the environment of that software. So that's all about our discussion on ISO 9126 quality definition model. And this also concludes our discussion on quality definition model. From the content we have discussed, we can observe that the quality definition models, in fact, contain the quality characteristics and attributes that help us in defining the quality in different situations. The materials in this video are based on the chapter titled Software Quality Models and Philosophies. This chapter was published in the book Software Quality Attributes and Trade-offs. For more details, you can consult the book. Thank you.